Hello students, so this is introduction and derivation of infinite series. So today we will cover three series. One is this 1 plus x raised to the power n, second is e, third is e raised to the power x. Normally it is not given in the books. Where do they come from? Straightway students are supposed to remember them, but it is better to learn that where from they originate. So let us start with the binomial theorem. So a plus b raised to the power n. So a plus b raised to the power n, this is the normal expansion of the binomial theorem. I think you are all aware of that. So it expands like this: nc0 a raised to power n, b raised to power 0, nc1 a raised to power n minus 1, b raised to power 1, then plus nc2 a raised to power n minus 2, b square, plus like this. So last term is ncn a raised to power n minus n, that means 0, b raised to power n. So that, or it can be written as cnn b raised to power n, because a raised to power 0 is 1. Now we make some transformation in it. So suppose b less than a, so that means b by a, say x is less than 1. So this becomes equation 1 becomes a take a common, inside it is 1 plus b by a. So let's make something like this, divide this by a raised to power n. So it becomes 1 plus x raised to the power n, and that is equal to nc0, a is 1, so 1 raised to power n, x raised to power 0, nc1 1 raised to power n minus 1, x raised to power 1. I am simply taking it from here. A is 1, b is x, then a is 1, b is x, a is 1, b is x, and last term is ncn x raised to power n from here, b is x. So ncn is obviously 1. So this becomes equal to 1, nc0 is 1, then 1 raised to power n is 1 only, and this is x. We are opening this nc0, sorry, nc1 here. So nc1 is n factorial divided by n minus 1 factorial into 1 factorial. This is the when we open this into x. Again we open this nc2 into x square. So nc2 is n factorial divide by n minus 2 factorial and 2 factorial into x square, same x square. Similarly, this is rth term. Rth term is n factorial divided by n minus r factorial into r factorial, x raised to power r, plus this is the last nth term. Now this was applicable for any n as per your syllabus. I am not going deeper. This is applicable for x less than 1 when the series becomes infinite. When the series becomes infinite, so x, higher powers of x, they become smaller and smaller, ultimately reducing to 0. So only the first few terms of the infinite series are useful and enough to evaluate the function. So this gives us a good expression: 1 x raised to power n is equal to 1 plus nx from here plus n into n minus 1 x squared 2 factorial plus n into n minus 1 n minus r plus 1 into x raised to power r divided by r factorial. This is rth term. This is the expression given in NCERT books? First, this we have derived from binomial theorem. Second is, what is E? You must have heard Naperian logarithm, natural base, E. So, what is that E? How it comes, how and where from it comes? Usually students are told that this is the series and this is called E, and you just remember, but I am giving you the derivation. In this expression, if I put n is equal to 1 by x, so that xn is equal to 1, and when n tends to infinity. So, you can see in equation small I 2i, equation 2, when n tends to infinity, so this x tends to 0, but their multiplication is always 1. Say I say n is 10,000, so x will be 1 by 10,000. So, that will be very small, but multiplication of 1 by 10,000 and 10,000 will always be 1. So, when I put here x is equal to 1 by n and n tends to infinity, so this expression becomes 1 plus 1 by n raised to the power n. So, simply keep substituting. In place of x, I substitute 1 by n. So, n into 1 by n, 1. Now, come here. Here I put x square 1 by n, so that will be 1 by n square. Now, students, see what is n and n minus 1. When n tends to infinity, so n minus 1. When n tends to infinity, so n minus 1 equal to n minus 2 equal to n minus 3. When n tends to infinity, because n is very large, say n is 1 lakh. So, 1 lakh minus 1. So, 99,999. So, they are almost equal. Similarly, when you reach further higher orders, 10 raised to power 10 minus 1 is almost equal to 10 raised to power 10. So, here when we expand it, n into n minus 1 x square by 2 factorial. So, this becomes n into n minus 1 n square, this is x square is 1 by n square. So, they cancel out n square and 1 by n square. So, here what remains is 2 factorial. So, series becomes 1 nx 1, then again n square divided by 1 by n square, 1 by 2 factorial. Similarly, like this 1 by 3 factorial, this is up to infinity. You can write 1 as 1 by 0 factorial, this is factorial, this is 1 factorial. So, 0 factorial, 1 factorial, 2 factorial, 3 factorial up to infinity. That is how we define E. So, this is your second series given in the NCERT books. So, third we come to e raised to power x, because already we are using x here in terms of n. So, let us say e raised to power z. So, what is e raised to power z? What the series will become? So, that is again very simple to derive from e. E raised to power z means this is e. So, this is e power z, that means 1 plus 1 by n raised to power nz. E raised to power z is equal to 1 plus z square by 2 factorial plus z cube by 3 factorial and up to infinity. So, we have covered 3 series, 1 plus x raised to power n, number 1, then e, number 2, then e raised to power x, number 3. In our next lecture, we will cover the last one, expansion of log 1 plus x to the base e is equal to what?